Welcome back. Today we're going to be taking a look at power cords and specifically how to put together an extension cord. Now, I don't intend on this being a very long video, but there are some things that I do need to talk about before we can just go into putting this together. Now, first of all, the question comes into mind: what are you actually using the power cord or extension cord for? That's going to make all the world of difference, picking out what kind of cord you're going to use, what kind of end you're going to use, and so on and so forth. There's quite a lot of questions to ask yourself, and I kind of put together a little chart to help us out with this. Before I get into all that, we have the basics of the matter. Now, this video will work if you're trying to make a new extension cord, or if you're trying to repair an old one, or if you're making a power cord for an electronic component you're putting together, or you did like I did and you salvaged another piece and you cut the power cord off and you want to make yourself a short extension cord. And like I said, it's basically the same technique for all the methods I'm going to mention, but I figured I would point that out. Also, the two pieces that you see here in front of you, the receptacle and the plug, these are actually as old as I am, if not older. They are part of my dad's collection from when he did a lot of electrical work, and these are the kind of things that you just, kind of buy in a case when you're doing a lot of extension cord stuff. And he was actually making his own cords. You would just go out and buy a spool of, whatever type of cable that you would most likely use. And then you just, like I said, get a case of these ends. And then, you can make the cords to fit your needs, basically, which is great. But I just have, this short cord. I use this to plug in behind this desk here. And then that gives me an extra outlet up on top here. I don't need a lot of electricity up here in the desk because most of the stuff I do is low voltage and I have plenty of power for that. But I do once in a while need this. And I actually have a lamp with the outlet built into it, but this is good if I need, like I said, that second source. Or, maybe you have a couch or something and you need to get that lamp plugged in, but it just doesn't quite reach the outlet. So you just need a short cord. You don't really want a long one. And that's what this is perfect for. I think this came off of an old, power strip or something, like a surge strip that wasn't working any longer. And I tested the cord out and found that it was fine. And I just, like I said, grabbed these out of a box my dad has in his basement of a bunch of them. And I was looking at them and said this would actually be a good video to shoot. And, well, I'm going to get into it now. So let's clear the desk off here. And we'll get into some of the questions like I mentioned. Now, first we have here is a chart which basically shows you the length of wire required versus the amperage rating you need. And if I point out a couple things here. When I say cord, the cord is the whole assembly with the inner wires. So each of these pieces, you can see two of them here, the third one's kind of blurring into the camera a little bit, but that's your wire, and then this makes up the cord. So that's the difference when I say cord versus wire. So a cord length of 25 feet, and depending on how much amps you need to get out of it, depends on what gauge wire you want to use and what, type of cable it's called. So if you see a light duty cable that's 25 foot, it's probably going to have 16 gauge wires what's inside the cord. So it's pretty self-explanatory. I will actually put this down in the description as best as possible, or give you a link to a site where you can find this information yourself. Actually, I can point out the Home Depot site had a really great write-up on all the different pieces that you're going to see here. And I did base most of this on their sheet that they had online, and some of the stuff I kind of already knew from working with it myself. I'll get into frame here that AWG stands for American Wire Gauge, which is the wire diameter, and again, that's the individual wires inside, not the cable as a whole. And if you need to find out what the amperage is, this is basic Ohm's law. So you're going to do watts divided by your voltage, which in our case we're using 110 volts, and that's what's going to give you the amperage. Now, a thing about amperage, most plugs, or most outlets I should say here in the States, have a 15 amp circuit breaker attached to it. And when you get into the different plug types, it makes a little bit more sense. You can't plug a 20 amp rated plug into a 15 amp rated outlet. It won't have the right connection for it. But I should point that out, that some of the ratings on here do go up to 20 amps. And you know, it's a universal language basically between all these different, you know, ratings. So what I'm discussing today, using a 110 volt 15 amp, you know, scenario, it's basically the same premise when you go to a higher current. You know, you're just going to follow a chart like this that's going to tell you what your readings are. And as you can see, as you go up in length, the gauges are going to change. In fact, when you get to 150 feet, you're using 10 gauge for your 11 to 15 amp rating, where you were using 14 gauge. And I'll also point out, the smaller the number, the thicker the wire. So a 10 gauge wire is thicker than a 14 gauge. It's going to carry more current, and that's the important part. That's what you're looking at, is how much current you need that wire to carry. Very, very important. That's going to keep the wire from overheating on you. If I flip this over, you can see that they're the different type of plugs. Now this is the NEMA, the National Electrical Manufacturers Association. And this is, again, a rating we have here in the States. The plug end of it is called a NEMA 5-15. Now the 5 is the different electrical rating, and the 15P means the 15 amp, and P for plug. And you can see this is the kind of schematic view of what it would look like. And if I hold it out like this, you can see the white pin on this particular one is not the wider pin. On a lot of two-prong plugs, there will be one that's wider, that's for polarity protection, but since there's a grounding pin, you don't necessarily need that, because it's only going to plug in one way anyway. But they do point that out, that it does normally have a wider blade. And you have one that's white, one that's your ground, and one that's your hot. And I'll get into that in just a moment too. And you can see that this is a 125 volt 15 amp rating, which it actually does say stamped on the plug, but you may not see that on the camera. It's right here. The other side is the 15 or 5-15R for a receptacle. And you can see that's that guy right there. And that's the same schematic as over here, except obviously it's reversed. And this one, you can see this blade receptacle here is wider than the other one. So if you do plug in a two-pronged plug, it's still going to have the same rating, the same, you know, polarity. You can also see down on the bottom of the list here, I point out the colors of the wire. So your neutral wire is going to be white, and that connects to a silver screw in here. You can see the silver prong. Whereas your black, which is your hot line, that connects to the brass screw. You can see that the other terminal is brass. If I hold them like this, you can see the comparison of the two colors. And then your ground, which is going to be the green wire, goes to the green tinted brass kind of screw. And you'll see that once we open these up. It'll become a lot clearer. So far we have an idea what kind of wire we want to use based upon the length and the current needed. We also have an idea what size plug we're using. Now this plug is going to determine what outlet it's going to be plugged into. So obviously this is a 15 amp plug. It's only going to plug into a 15 amp circuit. So it's only going to fit a 15 amp receptacle, so on and so forth. Again, this equation is going to be similar across the board depending on what amperage you're going to use. So if you're using a 20 amp line, it's going to be a 20 amp plug with the proper cord rating. And it's fairly self-explanatory once you start looking at it. The next sheet I have here is more of a wire type sheet. And this is basically stamped on the wire, if it's at least of a good quality wire. And it tells you what the different ratings are, the different usages. See if I can zoom in just a little bit for you here. Now, we do have a sample wire that we're going to put together, and to save trying to get it blown up on the camera, if I get close enough, you can probably see it on here. Sometimes it's printed, sometimes it's stamped like this. backwards. You can see that code kind of stamped in there. What that code is, it's this right here. Now that breaks down to meaning a certain thing here. The UL listing means it's Underwriters Laboratories listed. That's a third party that does testing and safety and whatnot. And they rated this as being a safe cord. The SJT designation, which we saw up here earlier, means that it's a flexible cord with 300 volt insulation and the jacket's made from vinyl thermoplastic. Pretty straightforward. This code, this E135710, is the manufacturer identifier code. I looked that up online, and a variety of different codes by this wires, I should say, different cord sets came up by the manufacturer. Some were 2 conductor, some were 3 conductor, so it's definitely not specific to this type of cord. There was 14/3 stamped on there, which means it contains 3 14 AWG wires, and that stands for American Wire Gauge. Again, that's the diameter of the cable. It had VW-1 stamped on it, which is the vertical wire flame test. That basically means that they take this wire, they hang it, they apply a heat source to it, it'll start to catch flame, and then when they remove the heat source, the flame should diminish and extinguish itself due to a flame retardant. I'll put a link in the description below more about that test as well. Bon Eagle is the name of the manufacturer, and it had F3 right after Bon Eagle, which is one of their identifier codes. Again, same thing with that. I looked up Bon Eagle F3, and it doesn't. Some had Bon Eagle F3 after it, some didn't. So I'm not really 100% sure what that code is, but the important parts, we know what that means. So that's basically the theory part of it. I didn't want to get too in depth with it because that's kind of beyond the scope of this video, but there are some things, like I said, you should know. The other thing I should point out, if you are uncomfortable working with electrical circuits, specifically mains voltage circuits, stop right here. You know, this is good, informative kind of a video, but once you actually start delving into stuff where you're handling something that could actually be plugged into something else, you want to be careful. You don't want to actually go ahead and shock yourself or assemble this cable in an incorrect manner and have it be unsafe to somebody else. But if you are comfortable with this kind of thing and you want to go ahead and attempt this, then thank you for staying. We're going to go ahead now and do a little bit of a breakdown on these 2 ends here so you can see what's entailed with them. Now, like I said, they're old. This is what you're going to call new old stock. It's been sitting in a box for a long time. They've got to be at least 30 years old, no lie. If not, like I said, they're older than I am. But the principle is exactly the same. In fact, this company, Hubble, is still around today. You can actually still pick these up. They're a little different in design, but they have this exact same principle. Now, I believe this was back in the time where Phillips head screws weren't as popular, because you can see the case screws here are flathead. So we'll go ahead. The first thing we want to do is loosen this strain relief up. You don't have to take it completely off, although depending on how thick your wire is, you might want to do that. But in this particular situation, we don't need to. So I'm just going to go ahead and just work this off to a comfortable working distance. Now, I know flathead screws have been around a lot longer than Phillips screws are, but I love Phillips screws. They're so much easier to work with in a sense. You don't get them sliding off over here. All right, the front just unscrews simply, but you can see these screws actually twist out really quickly. They have a really sharp taper, I guess you want to say. You can actually see, if I get a close up here, they got like a funky taper on it. And this is your plug end, and the strain relief and body part are actually exactly the same on either one. So if you take these both apart, you don't have to worry about mixing them up, which is a great thing. We're going to go ahead and repeat the same thing on this side. Now, if you were making a whole extension cord, obviously you're going to need one of each of these. In my situation, I'm only going to need the receptacle end of it here, because the plug end on my cord is molded on and it's in great shape. Now obviously molded plugs are a lot better in the beginning, I'll say, because you know it's the durable rubber molded or hard plastic molded piece that's connected right to the wire. This doesn't have as best of a strain relief. Some of them have like a nice rigid kind of, I should say flexible, like rubber kind of strain relief on it, but it's fine for something that's just going to be plugged in. I think, like I said, this was part of a power strip, so this is more of a permanent, it's plugged in and you don't really move this around a lot, whereas something that, well, actually like this extension cord over here, for this power strip I should say, it's battery charger. You can see how it's got this accordion kind of style strain relief, because this is the end you plug into a laptop. This gets a lot of wear and tear, so obviously you're going to need something like that. And here's the AC wire. You can see here's the rating on it. So this is an 18 average wire, American wire gauge 2 conductor. I know it says American wire gauge. I always say average wire gauge in my head. It's just one of those things. I don't know why I do that, but yeah, American wire gauge. Again, UL listed, manufacturer's code. This is probably some kind of a certification on here. Here's the VW1. Here's your type SPT-2. The P means it's parallel, so you can see these wires are together here, side by side. So it's a little off the cuff kind of show of another power cord, but you can get an idea how these principles are pretty universal to different wires. But anyway, back to the receptacle. We'll go ahead and take the front of this off. And once you get inside here, you'll see these things are fundamentally the same. And that's it. Now what's nice is they have a clear inner body on it, so you can actually see the wire go into the clamp. See if I can get a close-up of the money shot here. You can see here's this screw goes directly to this terminal. So is that one, and so does the one on the bottom. And just like I mentioned before, this is the green brass screw, so that's going to be your ground wire. This is the bright silver screw, so this is going to be your white wire for your neutral. And then this is your brass screw, which is going to be the black wire for the hot side of things. Now I hope I can show you on the camera here, they actually have a little strip gauge. It actually shows you right here. It says insulation, and it goes from here with a little arrow all the way over to about the midpoint right here, which you can see right about here where the tip of my finger is. And then there's another one here that says wire, and it starts from here and goes over. And what that is that's a recommended strip gauge. So you're going to want to take your wire here, your cord set, and you want to strip the jacket back to a length, the distance of the whole piece here. So you can see from here to the end, this much we're going to strip off. And after you get that out, we're going to strip back the insulation on the individual wire here, the distance of the smaller piece here. I'm going to pause the camera, draw that out in paper to try to make that a little clearer. Now what that looks like when you get it up close and draw it out, it looks like a rectangular box with 2 arrows on it pointing in either direction with the word insole for insulation, and then there's a smaller box right below it that has wire written in it with the same 2 arrows in a line. So like I said, you're going to cut back the outer jacket, the length of this total thing, so that would be this here, and this isn't to scale obviously, but So you're going to cut back the jacket that far. The insulation is going to be stripped back this far on the actual wire. So you'll have the cord with 3 wires coming out, and the 3 ends will have insulation so far back. And now we're going to go ahead and do that with this actual wire. Now the wires inside the cord here, I have a stripper for. The outer jacket, I do not have a stripper for. So I'm going to actually do this a slightly dodgy way that honestly, unless you do this a lot, I don't recommend doing. And I'll show you why I don't recommend doing it when it's done. But I'm going to use a razor here. And I'm going to take this and very, very carefully, I'm going to go around and score the outer jacket of the cord with this razor blade, the length I need, and slowly start to wiggle it back and forth gently enough so I don't mess the wires up inside of it, but the outer cord will, jacket will become weak, and then eventually I can just snap it right off. Now if you had the right tools for this, which unless you're doing this a lot you wouldn't really have, but you would get a stripper that you can just put right around this, and it's basically well, it looks kind of like this. It's got a blade with a notch cut out of it on both sides. So as you put the wire in here, that sharp area inside here is just wide enough to kind of like cut this as it goes through, but it doesn't cut the wires under the jacket. And then you can just like kind of wiggle it around and it just, you know, pulls right off. So I'm going to go ahead and pause the video here, and like I said, I don't recommend doing it this way, and I'll show you why when I come back. Now you can see I went ahead and carefully just sliced around here with the blade and wiggled, and you can actually watch it break away as you do it, and then you just wiggle it and you keep going until you get around and you can slide it off far enough. And you can see on the green wire here there's a little bit of like this powdery kind of material that just allows this jacket to slide easy. So as this cable flexes, the inner wires inside of it are able to move kind of freely, which is, you know, what you're looking for in a cord as well. You don't want a stiff cord. But the reason why I mentioned you shouldn't really do it this way is as you're cutting along here, you actually can see the parts in between the individual wires are thicker than they are on the outside, because they're actually twisted as they go through here. And you actually risk nicking that inner insulation. And trust me, sometimes this inner insulation is kind of on the chintzy side, where just the slightest bit of abrasion causes this to start just fraying immediately. And then once you get any kind of a kink in it, it just completely exposes all the brass underneath, and that you definitely do not want to do, especially on the black hot wire. And if it happens in between, you know, you can actually short this out and you plug this cord in and you keep wondering why it's tripping a circuit breaker, and it's the wire. But like I mentioned, I took the back of the panel here and I held it up and just kind of marked it so I can get the gauge right. Then you just want to slide this off. Now you see there's our 3 individual connectors, and like I mentioned, the black is your hot, the white is the neutral, and the green is the ground. Now we want to go ahead and take one of the ends that we've went ahead and loosened the strain relief on. In fact, maybe give it another couple twists of the screwdriver here just to get it a little looser. And we're going to stick the wire through the back and just let it loosen the wire. And trust me, there's been times where I've actually forgot to put this on, just putting cords together in a haste, and had the end of the cord on and gone, uh-oh, where's the sleeve? If you're making a short cord and there's nothing on the other end of it, it's not such a big deal. But when you have 150 feet and you're already to the other end, you're not going to want to, you know, take everything apart in both ends. So you just kind of have to undo what you did and fix it. But like I said, we're going to go ahead and slide this down. Now we got the end here, we have to strip these wires. And I'm going to go ahead and use one of these multi-stripper tools over here. You can see it's got the different wire ratings over here. This is your commercial American wire gauge again. And we said that this was a 14 gauge wire. So I'm going to use this pin right here. So you see here's your 10, here's your 12, here's your 14. And this is, you know, the easiest thing you're pretty much going to do. Just pop this through the other side here, crimp it down, and pull it off. And I'm going to go ahead and measure the back on this here, just to make sure, again, they're right. You can see right here's the wire portion. So it's going to cut right about here. It doesn't have to be perfect, but you want it to be pretty close. So we'll go ahead and put this on 14. Pinch down and pull off. And you see I'm kind of holding it tight as I pull it. And then I usually just give these wires a good twist. And you can see this is what's called a stranded cable. There's multiple little strands, like hairline strands of cable in here, as opposed to a solid core wire, which would just have one strand. Now typically extension cords are going to be made out of these stranded wires, and the wires that are in your house running through the walls are typically going to be a solid wire. And there's reasons for that, but that's pretty much beyond the scope of this video as well. So I'm going to go ahead and pause the film here, and I'm going to do the same cut on these two wires in the background here. So all three are going to be the same distance apart. Alright, that's done. I'll actually show in the back of the strippers here, they do have a recommended wire strip gauge for inserting them into terminals or doing wire splices, which is pretty handy. You know, these things actually are pretty beat up. I use them quite a bit, but they are very handy. I've used them to cut studs. I've used them to crimp, you know, butt connectors and all that kind of fun stuff. It has wire cutters built in. Yeah, it's, you know, again, they're probably older than I am. These are part of my dad's old tool set. Kind of just made them my own, I guess. He has quite a few different ones, and you know, with mine is his kind of principle, I guess. So here they are in my shop. So anyway, we're going to go ahead and put this together. Now what we do have to do is loosen these terminals out, and sometimes you buy them, they're already loose, or already open up all the way. Sometimes they're not, but these ones are actually open. And you can see in the back here, there's these holes, and the wires are just going to insert in, and you're going to tighten them down. I suggest doing one wire at a time. I also suggest lining these wires up with the proper terminals. So we've got, again, the brass screw is going to get the black wire. The white screw is going to go into the, the white wire is going to go into the silver screw terminal. And then the green is going to go into the ground, which is this brashish kind of green screw. And you can actually hopefully see this clear body here. You can actually see that ground cable go all the way down into that terminal. And once I screw this clamp, you'll actually see that engage in there. And I give these a nice good tightening. Now I mentioned before the molded plugs are a little better initially because they are molded and whatnot, but once they go bad, you kind of have to cut them off the plug, and then you have to put one of these on. I noticed that some high-grade power cords already come with these on them because, you know, they're field serviceable. It allows you to change them out whenever you need to, which is good. You can customize the cord if necessary. I've even had cords be in a little bit more of a permanent situation where they had to get passed through a hole, so you could take the end off, pass the cord through, and hook the wire back up. But depends on, you know, what you need it for. Now once I get them tight, I want to go back around and just retighten these to make sure they're all on there nice and good. And that's it. I mean, you should have a little bit of, you know, insulation space back here just to keep these wires from going all over. Oh, and sorry, mind the charger for the camera. That's it. All you have to do now is just slide the body back on and then find, this one has a tab and a spot the tab lines up in. You want to take this faceplate here, we'll call it, and just screw them back in. Now these don't have to get too tight because they bite really good. You'll feel them as they go in. That's it. And then the back here, we just want to put the strain relief on. Now as you do this, you're going to want to work it down corner by corner. So we'll do that side a little bit. We'll switch to this side. And you want to get this thing as tight as you can get it. It's going to prevent that cord from being pulled out of this connector here. In fact, you should be able to get this all the way down because there's like these channels inside here. Yeah, that's perfect. You could see it biting down that cable. These channels in here kind of line up and the cable kind of just pinches in there, and that makes a very, very strong cable assembly. You know, this is not going to unplug very easily, which is what you want. In fact, I can actually take the other end here. I'll just assemble this really quickly, which again, it doesn't matter which end you're doing, it's the exact same thing. So whether you're putting a plug end on or the receptacle end on, or you're making an entire cord setup, it's the exact same thing on both ends. And I will point out, I've heard people tell me it doesn't matter what colors you use as long as they're same in the both. And while that's not entirely wrong, I always say that's a dangerous practice. These things have color codes for a reason. They should be set, you know, where black is your hot, white is your neutral, green is your ground. That's how we do it here in North America. I know other parts of the world do it differently, but you should be following the color code for your given locale to maintain safety. You know, the next guy who opens this up might not know that you put green to be hot and you did neutral on black and whatnot. You know, again, if you did the same on both sides, yes, it will work, but that's a practice I don't recommend doing. But anyway, I can go ahead and show you this. Yeah, that thing plugs in there nice. These are good plugs. I've always had good luck with these. And if you wanted to, you can make another cord, you know. What I've actually done is I've had situations where a device I use, let's say, needs you know, 25 feet of cord or 20 feet of cord or whatever the scenario is. And, you know, you have a big long extension cord and, you know, power rating withstanding, the cord's just too long and you need to lop off some length of it. Just, you know, get yourself a set of these, cut the wire to length as needed, and you're good to go. What I'm going to actually do is again, I'm going to pause the video. I have a little circuit tester for AC usage. I'm going to bring out my toolbox and we're going to test this cord to make sure it works perfectly. And I'll be right with you. And here's the tester. This is just a simple device you plug into a grounded outlet and it will tell you if this thing is working basically. Let's see if I can get close enough where you can read this. Now you see it can indicate correct wiring, reverse polarity, an open ground, an open neutral, an open hot, hot and ground reversed, and hot on neutral, hot on wired. So there's a variety of conditions. There's some it does not test, like ground and neutral reversed. It's kind of hard to tell because neutral in most of these situations is neutral, is set back to ground anyway in the actual electrical, in the circuit breaker panel. Quality of ground, yeah, it doesn't have that kind of test to it. Combination of defects, you know, again, that's all stuff that you're going to use on a, you know, higher end kind of tester. And I can tell you this doesn't test ground fault circuits either. But you could see here's the 2 indicator lights. As long as these 2 light up and the red one doesn't, you're basically good to go. So I'm going to go ahead and plug the extension cord in, and we're going to plug this into the end of it, and hopefully these 2 lights light up, and that will indicate that everything's right. Of course, I don't want to sound conceited, but I'm pretty sure it's going to be right anyway because I did follow the proper code. But you know, I want to test this out to make sure that the cord isn't internally shorted or anything else out. Plus it's good practice to do this anyway. And of course, make sure you plug this into the outlet you're testing the extension cord on first to make sure the outlet's actually right. Well, so far it passed the first test. I plugged it into the outlet and it didn't turn the lights in the house out and pull any circuits, so that's always a good sign. But to go ahead and confirm, we're going to just plug this right in, and I don't even have to go in all the way. You can see that those 2 lights are lighting up. And that's it. That's all there is to it. So if you follow the instructions correctly, you should be able to go ahead and, you know, go to the hardware store, pick out the proper ends that you need, pick out the proper cord size that you need, and build yourself an extension cord. I hope that you found this video informative. If you like watching these videos, I appreciate you subscribing. If you're not, if you are a subscriber, again, thank you for, you know, returning to the channel for more videos. I do enjoy doing these. I'm going to be having a lot more in the future as I get to them. And as always, thanks for watching.